Good evening, everyone. Am I audible? Okay, thank you, Mayank. All right, let's wait for 2 3 minutes more. Thank you, Karthik. Then we will start today's session. Okay, and make sure to have your paper and pen with you because we will be doing some numerical related to neural network today. All right, let's start our session. Okay, so welcome you all once again in the course for the introduction to machine learning, supervised by Professor Balaraman sir from IIT Madras. Okay, so here we are going to start our week 5 session. Till now we have an idea about machine learning. There are three paradigms: supervised, unsupervised, and reinforcement. We have started with the supervised paradigm, in which there are two types of problems. So first is classification and second is regression. So in week 2 we have started with the regression problem. We learnt about simple regression, multiple regression, the different variants of regression, including some regularization techniques, right? After that, we started with the classification problem, that what is logistic regression, what are discriminant functions, and how to map a hyperplane using perceptron and svm, right? So in the last classes we have gone with some classification techniques. So here also we are going to learn about a powerful tool of machine learning, that is called neural networks. So the major portion of this session will be towards neural network, and some of the portion we are going to study about some parameters. Okay, so till now we have a same problem, that we are having a problem of optimization, where our main goal is to optimize the parameters or weights of the network or the algorithm that we are using. Okay, so for in this aspect, now we are going to study about artificial neural network. So this is the major one of the algorithm that you can say that we are going to study about today. So for this artificial neural network, obviously the optimization plays an important role. So for optimization, the technique is backpropagation, and we have gone through this technique a little bit in the last session, called as gradient descent. I started talking about it, but I told you in the last session that we will discuss this in detail. So we are going to discuss this in this session. Secondly is parameter estimation, because all the things that we are going to study here is related to probabilities in classification, and you can say some betas or weights in regression problems. So ultimately we are defining some probabilistic functions. So those probabilistic distributions has some parameters. So how to link with this? So we are going to study about that. Okay, all right. So let's start with artificial neural network. So let me know this. How many of you have heard the term artificial neural network? Just raise your hands, or you can say just, just give me a thumbs up, so that, okay, okay. All right. Many of you, right? So many of you have heard this term. Second term now. Have you heard about the term deep learning? Yes or no? Yes, yes, right. So basically, you can say that artificial intelligence is a big block in which one of the characteristic is machine learning. Okay, so if I say that this is a big block of artificial intelligence in which multiple things are going on, and a small part is here machine learning. No worries. So we have started with how to make the machine more intelligent, right? So in this there are multiple algorithms we have done with regression, we have done with svm, we have seen logistic regression, right? So these are different algorithms. So one of the algorithm is artificial neural network. Its advanced version is called as deep learning. So deep learning is nothing, it's a subset of machine learning which particularly using this artificial neural network in an advanced way. Okay, so it has too many parameters. If you have too many parameters, it means you have too many choices to make. So from these choices to a simple neural network, from a simple neural network to advanced neural networks, this is a study that we deal with deep learning. Okay, so that's why this algorithm is of main concern in today's era. Okay, so let's start with this. So artificial neural network, we have already discussed perceptrons, right, in the last class. So here these artificial neural networks are inspired by brain architectures, as the name signifies, neural networks. So ultimately there are two scientists. One is a neurologist who know the actual functioning of a brain from a human, and another is a logician. So this logician means the person who knows about these gates, right? So ultimately, what is your system, what is your computer? It's based on the logic gates, whether true, false, yes, no, right? So all these things that you have learned in your digital logic classes, so this logic is behind this screen. So these software are just like the myths. Okay, so software is nothing which you can the actual thing in your computer is just the hardware. It's just that something is combining it up, and it seems like, see, something is on the screen. It's just that some pixels are lighting up and you can visualize some scenery on your screens. So ultimately, things are, some logics are creating behind this machine. And so the scientists, first is neuroscience, second is mathematical models, so these two important branches are converge to form this artificial neural network. So here our main idea will not go towards neuroscience. We will discuss about the mathematical and computational models here. So the very first model is, first thing, let's discuss about what is neuron. So let's start with this small introduction, that how it has started. So what happened is, when this term artificial intelligence coined, so people say that what is artificial intelligence? It's a concept of intelligence into the machine. Now question arises, what is intelligence? Who is intelligent? So the answer is, only the from because God has made us here on this planet, human is the most intelligent mammal or animal on this planet. Maybe some animals are also there, but they are not able to speak, right? So we are the most advanced version of our species. So why we are intelligent? Because we have this a box that is called brain with us. So how this brain function? Here, when the brain functioning comes into picture, they say, let's simulate this brain function to this machine also. So that's why they coined this term artificial neural network. So first of all, they say, what is the main functioning of the brain? How you can see from this diagram, right? So here you can see that this is a simple diagram of single neuron, and our brain and our nervous system is created with multiple neurons connected to each other, right? So it means that information is passed from the environment to the brain, and again the action is passed from the brain to the particular organ. For example, if I am in front of a fire and my hand is going towards the fire, I can sense the heat. How I am sensing the heat? The skin tissues or the skin neurons is sending some signal to the brain, and that brain is giving the signal to my hand that please remove your hand, otherwise you will get hurt, right? So it means that this connection has a basic component that is called neuron. So what is neuron? Here the diagram says that there are some dendrites which is taking the input from the environment and passing it towards the body to the next neuron, right? So similarly, we simulate this in a simple mathematical model. So what we are doing is, we define this complicated architecture of neuron as a single circle. So this is called single neuron. So what we are saying, we have also an environment. This is our environment, or you can say input. So this input is feed in this neuron, and obviously it's not like that your environment can give input to single neuron. It, because our body is made up of multiple neurons, so it means that the information from this environment can be feed into multiple neurons. So this is your first layer of neurons. Now this neuron layer will pass all the information that is present here to the next layer. And similarly, finally, it reaches to the brain, and brain somehow predicts or analyze those signals and decides some action. So that will be the output. So output can be in different forms. It's okay, no problem. Now, we have to think about what is the processing of this neuron. Now we get an architecture. Okay, neurons are interconnected to each other. It means some input is coming to the neurons and the information is passed to different layers of neuron. It's okay, no worries. Question arises, what is the process of this a single neuron? Okay, so just think about this, because our body is made up of some biochemicals. So some chemical or you can say some electrical chemical equations are there inside our body. So what happens is when the information is passed to the neuron, some that conversion of signals happened, and maybe it transform the input that is from the environment to its own information. So basically what happens is, maybe let's say this is a neuron, the information is passed as X, and from this neuron some processing is being done here, and it has returned as X dash. It means this processing, what is this processing? This is just the transformation, right? So this transformation we are also going to do here. Okay, so basically, it means that you can see a single neuron is a processing unit in a system, that is we call this as a computer or a machine. So it means that a single neuron can be acting like a processing new unit in our system. So it means that there is a CPU, there is some process going on. So this is a function 1, it means neuron 1. Some inputs are passed here, some processing is being done, and some output is taken out from this neuron. Similarly, from the second neuron, same thing is happening. So it means that this is the web of neurons which create the actual concept of artificial neural network. So that's why we are saying these neurons are connected in complex networks. So how these networks are, what is the architecture of network, how these connections are made, which of the connections are important, which are not important. So these complex topics creates a whole subject of deep learning. So different types of neural networks, that if you know, these are dependent of different connections or architectures or functions. So we are going to study that how are the basic of this neural network works, so that if you will have an idea of other advanced neural network architectures, you can easily go through that. Okay, so the very first model, when it has started, the very first model is McLeod's model. So the two scientists that I have told you about, one is the logicians, second is the neurologist. So these are the two scientists, McLeod and Pitts, and they devised a very simple type of model. They say that there will be some input signals. Okay, so let's say these weights are 0 or 1. So don't worry about these weights. 0 or 1, or you can say minus 1 or 1. It can be like that. So they say that some inputs are given to a neuron, and the function that is processing in the neuron is a summation function. Okay, so they are saying it's just the linear combination. So what they are saying, it means that x1 is there, x2 is there, x3 is there, and x4 is there. So what we can do, x1 plus x2 plus x3 plus x4. Okay, now they say that some of the inputs can be excitatory or inhibitory, means that can be included or that cannot be included. It means that that's why they introduce this weight term as minus 1 and 1. So whether this input has a positive impact or the negative impact on your output, it means it is excitatory or inhibitory. Okay, so what they are saying, inside a neuron, all the inputs given to the neuron gets combined up, and after that some threshold is applied. Why threshold? Inside our brain, when you let's say, I gave you an example, let's say when you are reading about this, let's say machine learning. Okay, many of you know about this, what is neural network, and when you give exams also, you try to remember things, right? You try to put yourself in a focus way. Okay, I have learned about this neural network, it's a McLeod's model. Okay, what is in it, what is inhibitory? So you put focus on the areas which you have learned someday in the past, but you did not able to recall it. Why? Because, and we say that the more you are going to practice things, the more you are able to recall things. Why? Because our neurons will get trained like that. Okay, yes, someone wants to ask anything?
No, ma'am, by my side.
Okay, so let's say some, you are reading some paragraph, right? So these text or anything that you are reading, it's like an input, and your eyes, because you are reading through your eyes will have those neurons. So all this information is going towards the brain through your eyes. When it reaches your brain network, the deeper the neurons it pass on, it has some threshold function. So if that threshold is crossed, it is passed to the next level or next layer of neuron. So the deeper the information is passed in the neural network, it means you are able to recall more. And if that information is quite, vague, or you can say blurred, you will say that, ma'am, kuch to yaad aa raha hai, but I am not able to recall things. Why? Because your information is not going deeper down your brains, right? Similarly, here also some threshold is applied. So if the output from this summation is greater than the threshold, then the output will be 1, otherwise it will be 0. So this is a basic architecture of neural network that Maclay and Pitts developed. Second thing, I told you that one of them is a logician. Okay, so logicians means he belongs to that electrical community, and he said that the basic model, the basic units of any machine is logic gates, and or not, XOR. Okay, all our systems are dependent on these type of gates and logics. So why not we develop a system of neural network for these weights only, for these logic, digital logic only. So they started with this model for and, or, not. Okay, so and the combination of these. So when they have started this model, they name it as Maclay-Pitts model, and it's a very simple type of model. And for that, they can simply use some activation function as threshold. So this activation function means, let's say you are combining the input, and some processing that is going on inside the neuron is based on this function. So ultimately the transformation part is based on this activation function, right? So this activation function is simple threshold. If your output is greater than 5, then it is true. If your output is greater than 2, then it is 0. It's more like that. So what they are saying, they develop this and or not gates with the help of this. You can see in the literature, or you can see on the internet, it is well defined equations. It's very simple. Question arises that our systems nowadays are very complex. It's not simple 0 1, it's not like and or. We have a much more complicated system. So this system that they have developed, they say that we have included the weights in the form of -1 and 1, simple weights. But it's not necessary, right? For example, you are sitting in your drawing room watching the television, a cricket match. Okay, so it means that you have 5 sense organs in which the input can be um, um, given to your body, right? So it means that your eyes, your ears are on your television screen, and you are so much into that match that you are not able to hear your mother's call. Let's say your mother is calling, "Ki, please help me in this way," but you are not able to listen properly because your main focus is on the screen. It can happen, right? Secondly, there are multiple things going around you in the environment, but those things are reaching to your body but not as a major input, right? Presently also I am talking something, right? If you are focused here on this lecture, it means other things that are going on in your environment may be different things, because you are all at the different places. So there will be different types of noises, different types of scenarios. Maybe some animal is there which is who is barking or something. Maybe some machine is going there. Maybe some of your colleagues are sitting doing their work. It means that there are multiple things going on in your environment, but you are focused on one thing. All these things are given input in your system, but what I am saying, you are focused on one thing. It means your weights towards different input are different. So it can't be just that -1 and 1. It should be some values, right? Maybe some more values given to a input which is more important that you are focusing on, and some other inputs can be neglected, right? So sometimes we say that na, ki the thing is right in front of your eyes, but you are not able to see it. So it's not like that it does not capture in your eye. It's just that you're not able to focus on that. The weight of that particular object is so low that you are not able to process in your brain, right? So for that, they put a small change here. Ki let's have these weights not just -1 and 1, but some more value. You can say that. So that's why if we include that weights as betas, okay, just think about this. Means I want to say the beta and the weights, I am going to use it equivalent in all our lectures. So this is a simple model that we have discussed in our last classes, your perceptron model. It's a simple way. Simple. But the major drawback there was it is specifically used for linear. So it can't handle non-linearity. That's why we come towards SVM, right? So here also in neural network, if all the processing, it's just that we just change the architecture of our algorithm. The main goal is same. The main equations are same. Nothing is different. It's just that if we are going to use simple these equations, it will be used for linear subjects or linear problems, but our model should be robust enough so that it can handle non-linearity as well. So for that, they somehow use some advanced mechanism which we will be going to see in the next slides. Okay, so first thing that they included in perceptron with the difference in MacLipit's model, that there are no inhibitory inputs, means -1 and 1 were not there, but the weighted summation. So it's just these things are different, otherwise all things are same in the MacLipit's model. So now we can say that this perceptron and MacLipit's are somehow similar, and we can use the information of each other to each other. But as I told you, the problem is with the non-linearity. So non-linearity means, just think about this. This is 0, this is 1, and this is 1. Okay, so just give me the output. What will be the output for AND gate? Just open your
Just
mic.
open your mouth. 0001.
0001. Very good. Or for XOR?
0110.
0110. Okay, now plot this. Let me plot it. First, I will plot for AND. For 00, it will be here. Okay, this will be 0. For 01, it will be 0. For 10, it will be 0. And for 11, it will be 1. I am going to use this open circle for 1 and close circle for zeros. Okay, so if I have to classify this 1 and 0 problem, I can simply place this line, right? It's a simple linear problem. This is AND. No problem at all. But think about, I am doing for XOR. So for XOR, 00 means 0, 1 means 1. Oh, sorry, 1 means 0, and it is 1, and it is 1. Can you place a single line to discriminate this XOR function? Yes or no? And single line can discriminate all these four into two classes, 0 and 1?
No, ma'am.
No. So this is
No.
a major. Yes. Any doubt?
No, ma'am.
Okay, sure. So basically, this MacLipitz also has this observation that for the linear function like and, or not, their system was working fine. But as they have wanted to implement for XOR, it is not working. So what they say that ki our MacLipitz model is only for the linear problems. We cannot handle non-linear problems. So they say that what can be the approaches that you can solve non-linear problems with the similar architecture. So let's discuss about that. So basically, okay, gradient descent, I will be talking it later. So basically, all right. So basically, they say that there are two ways. First is this activation function that you are using for thresholding, it should be changed. Maybe it is not proper. I'm not saying all threshold functions are linear. No, I'm not saying that. I'm just saying maybe this thresholding function that we are using for and or is not correct for the nonlinear problems. Let's change that. Secondly, they propose that why not we use some another function which are not thresholding, maybe some another mathematical function which can handle nonlinearity. So the first aspect is with related to activation function. Second is they say that because MacLipit's model is a single layer perceptron, it does not have multiple layers. So it means that all the inputs, it will give you some output. Simple. nothing in between. So they say that why not we introduce multiple layers so that it can layer, because after layer by layer the input is going through multiple transformations and it can introduce this non-linearity. Maybe it can happen. So they say that okay, what we can do, we can increase the layers, we can try it with different activation functions, maybe our problem will be solved. And in fact, using these two things, our system is able to handle non-linearity very well. So these are the two things that they have included in advanced neural networks. It means advanced means from the MacLipids. For our thing, we can say that these are the basic things that we are including in our actual neural network architectures. So here they say that okay, so same neural network architecture, same this basic knowledge can be applied with multiple layers and different types of activation function. Okay, so for that they say till now the output is generated because we are using simple thresholding. So thresholding means greater than something is 1, less than something is 0. So it means that we are discretizing it. How it can be used for continuous values, and if you are using for continuous value, then how can we optimize it? It's not like that. Now we are able to learn the things in the very first iteration. So we have to have some mechanism where we can optimize these networks. So for that they say that it's not easy to optimize using a proper concrete optimization problem. No, what we have to do, we have to use some iterative procedure. So for that iterative procedure they say gradient descent is a very important concept that we have discussed in the last lecture also. So what they say that these are already some functions. Okay, neural networks are also some functions. So because each neural network has some proper functions defined, and generally we define the functions on the layers, not the neurons. It means that let's say if there are 10 neurons in single layer, all those 10 neurons will be having the same activation functions. Generally we do that. It is not that it is compulsory, but we generally do that. Okay, so let's say this function is somehow like this. So here we want to find some minima. This is the error function, right? So for finding this minima, we process the networks using gradient descent. How does gradient descent work? We calculate the gradient value. Gradient means delta E by delta beta. Okay, so we get this gradient value and move in the direction of steepest gradient. Steepest means where the gradient is giving us the lowest value. So it means that here if the gradient is this, it means it is moving towards this direction. Okay, so that's how we can go towards the lowest steep. That's why we generally process minima problems in neural networks. Generally we go towards that. Okay, and going towards this minima, it should be some step size. So this step size neta, or in another terms we call it as learning rate. Learning rate or step size is important. It means large step means oscillations. It means you just think about this. You are coming in this class to learn about machine learning. Okay, so now you are asking me some question to learn. So if you are jumping too high, it means you are moving from one topic to another. If you ask me some question of regression, then ask me some question of classification, then I will answer you according to your questions, but you are not able to converge very easily. It means that you are oscillating from one step to another. It means some divergence is there. Obviously you are jumping the larger step. It means it will take you some less time, but still that you can be more diverging. It means that let me just draw this diagram very neatly. So let's say this is your graph. Okay, and you are here, and if your step size is quite large, so what you will do, if your step size is large, you can like this first step, maybe second step, maybe third step, maybe fourth step, maybe fifth step. So it means that it will take you more steps, right? So it means the oscillation, the divergence is more. So this is the neta is larger. When the neta will be lower, it means you are taking very small step size. It means what you will do, small step. it means that you are taking the lot more time, but because of these small steps you will be leading to convergence, not divergence. But if you are moving toward in a more faster way, it means you will be diverging, then ultimately some oscillations will be there. So it means here it is meaning with this sense. Okay, so in this way, how to optimize it, we will see. We will solve one question also here. So why this step size is important? Because if you are having this very small step size, then you have some problem. If you have very large step size, then you have some problem. Generally we keep the step size in like 0.001 or 0.0001 or 0.01. 0.1 is also a very large step size. Generally it does not work, so we start with this criteria. So this is not very high, not very low, it means it is quite very slow. Okay, so we start with these type of learning rates in our system, and then we optimize our methods. So first thing is this gradient descent. So we will be seeing this gradient descent. So in this gradient descent, we can say first thing is step size. Second thing is when to update. So for example, let's say you are coming in the class, you ask me one question, I answer you one question, then you update your learning mechanism. Okay, the now the thing is like that. Then you ask me second question, I answer you the second question. Then you update something. It means you are updating your weights inside your brain each and every question, each and every sample. But the problem with this method is maybe one of your question is out of syllabus. It means we are here for machine learning, but some of the student, let's say, ask me the question related to some advanced topic in computer vision. I know it, I can answer you, but now the whole class maybe get confused because you are updating your knowledge each after each and every questions. Okay, second approach is why you say, ma'am, why we are updating our knowledge for each question? Why not we update it after each class? So it means that what has happened in the class, we take a summary and update our knowledge after each class. It can also be a good option. But question is maybe in the same class multiple topics will be discussed. So the summary cannot able to handle all those topic individually. So what we will do, so we have a concept of mini batches. So what we do, we take a bunch of questions, let's say 6 or 7 questions. You ask me, then okay, now I get it ki from these question I have an idea that I can update my knowledge for this topic in this way. You will ask me some bunch of questions again, then I'll answer you for all those questions, then you update your knowledge for on the basis of those questions. So generally in our systems, when we use neural networks, we use the training in mini batches. So after each batch, the weights are updated. Second batch, weights are updated. Third batch, weights are updated. So this is how we do it. So this term of stochastic, this is called as gradient descent, is simple gradient descent. Okay, so stochastic gradient descent is where computing the gradient for entire data sets, updates are done on single point. Gradient descent means updates are done after whole class. Stochastic means single. And here we learn, generally we do it as in mini batch stochastic gradient descent. We generally follow that. So there are three ways. First, simple gradient descent, full data. Second, stochastic gradient descent, single. And mini batch stochastic gradient descent means some batches of data. Okay. If you have some question, you can please go ahead.
Come again, ma'am, please.
Okay, let me go again. First is this gradient descent, simple gradient descent, vanilla. Vanilla means basic. It means you will update the weights by seeing all the data at once. Okay, if you are saying it is stochastic gradient descent, stochastic means step means after one sample update, after second sample update, after third sample update. If you are n samples, you will update n times, but it is also not good. So what we do, we update in batches. So let's say the batch is called as mini batch stochastic gradient descent. It means let's say you have 100 samples. If you have, let's say, 100 samples. Okay, so for simple gradient descent, you will update one time. For stochastic, you will update 100 times. And for mini batch, you define the mini batch size. Mini batch. So the mini batch size is, let's say, 20 samples. Okay, for 20 samples, we will have updates for 5 times. So this is how, these are the 3 simple ways to update. Okay, all right, now it is clear?
Okay, ma'am. Clear, ma'am. Thank you.
Okay. So next thing is, because we are not working in perceptrons, perceptron only work in a single layer, or you can say for linear networks, right? So what we can do is adeline. Adeline is adaptive linear neuron. So it is similar to perceptron, but it outputs the continuous value. Because in the last class, we see that perceptron give you either +1 or -1, right? It is used for classification. Now we are giving perceptrons a twist that it can be used for continuous values, regression. So what we can use, that the final activation functions can be used in some of the way where it would output a continuous value. If it is giving you continuous value, then we have to be use some regression error in respective to classification error. So this is called adaptive linear neuron. So it's more like, these are the terms that you can find, means it is in your lectures. That's why I have included it. But otherwise, it's a simple thing that perceptron can output classification output or regression output as well. It does not have some another meaning. Now what we have discussed, that the problem with single layer, because till now the perceptrons work in single layer, so it is not able to handle non-linear problems, for example XOR. So now we have multi-layer perceptron. It means that we have input layer, then we have another layer, then we have another layer, and finally some output layer. So we have 3 layers: input, output, and in between hidden. So these are the 3 layers now we are going to work. So for hidden layers, there is no restrictions that you have to use only 20, 30, 10, 5 layers. No, you can use as much as you can. But the problem is, the multiple layers that you are going to add, obviously it will affect the system accuracy or errors. Okay. Yes, any doubt, any question?
Ma'am, so KNN, I can say that each node is a perceptron. Is it correct statement? Kind of.
Each node is a perceptron. You can
Mm,
say it actually, because you are saying that you are saying this is a neuron, right? So it has some inputs
okay.
and it is giving the output, and this is the input as well as the output layer. You can say it's a single layer. So you can say in that sense, yes, it's a single neuron that it is giving you some perception out of it.
Okay. Thank you.
Okay. Now activation function, we have used some thresholding functions. Here they are using some advanced function like sigmoid, ReLU. Any functions in mathematics that you have learned can be used here with one condition. The function should be differentiable. Always remember. We can't use the function which are not differentiable, otherwise it will not able to optimize your network. Using gradient descent, look, there are multiple optimization ways. Okay, some ways are evolutionary computing as well. I'm not including those ways here. The basic rule of optimization in neural network currently that we follow is dependent on this gradient descent. So it means that you need to calculate gradients. Gradient means differentiation. So if your functions are not differentiable, you can't use these basic functions. The thing is more like that. Otherwise, if you have some another way around to optimize your network, then you can go towards that. Okay, so if you are using gradient descent approaches, your functions should be differentiable. Any function you can use, but it should be differentiable. Okay, so now I'm not going to have the discussion on activation functions because it's already there. You know about different functions, their characteristics, so you can go through that. I am going towards a more complicated problem, that how to update weights. Okay, so ultimately this gradient descent approach is also called as back propagation. Back propagation means how you are propagating or updating your weights. So for example, it's more like that, it's based on the perceptron rule. Okay, so that's why it is called perceptron, whether it is single layer or now it is multi-layer. So just think of a human. What human do is, human comes in a class, it is start learning, and at the end of the class the teachers say ki look, these are your incorrect answers. Okay, then what it does, these incorrect answers, he go back to home, he recall everything ki, okay, this is my errors, let's update it. So it updates back. That's why it is called back propagation. So generally what we do is, we have some neural network like this is input, this is hidden, this is output. Okay, all are interconnected, and it's a term we call it fully connected. Fully connected means each neuron of the previous layer is connected to each neuron in the next layer. It means this neuron will be connected to both the neurons in the next layer, and both the neurons will be connected to every neuron. Okay, so this is called fully connected, full graph. Okay, so this fully connected layer, first of all, what we will do, we will calculate the output here, because we need to get the output, that what is coming out of this brain, what is coming out of this network. This is called forward pass, because it is moving in a forward direction from input to output. Now from here, the output, we calculate error, and using this error information, we propagate this error back towards the network. So that's why this process is called back propagation. What is propagating in the network back? Error. So the gradients of error are propagating backwards, and using those gradients, the information is updated. Information means parameters. Parameter means weights. So these weights in as initialized weights, these are very random and very noisy. Now, using this error information, they update itself as the human do is. When you come in the first class, you don't know anything. Maybe you have some misconceptions also. Okay, so you have maybe some noisy weights trained on your neural network regarding the topic, right? But when you attend some class, you get to know, okay, these are the things that I am deviating from the true values. It means I know something, but I am not knowing it fully. The topic is not known to me fully. Now after this class, I am able to connect it how far I am. So generally what human do, human does not learn from scratch, it learns from where it needs to be learned, right? So it is like the relative learning. So similarly also, the error is being back propagated in the network, and the weights get updated. So these are the steps that we are going to follow from the next slide, and we will see some question regarding it. So first thing is initialize weights, because we don't know the weights, so initialize it. Second is forward propagate, this forward propagation. Third is error definition, define this error. Okay, fourth is propagate this error backwards and update the parameters. So these 5 steps converge to whole processing of neural network. Now think about it, whether your network is in star shaped, whether your network is in bus shaped, whether your network is in some recurrent shape, whether some loops are there, everything will be handled from these steps. Just that you have to put proper mathematical knowledge at each step. If one neuron is connected with 5 inputs, then equation will be made for those 5 inputs. If one neuron is connected with 200 inputs, equation will be updated for 100 inputs. So this is what we have to be taken care of. Otherwise, all the basic things that we are going to discuss about these 5 steps will be followed till the most advanced neural network here. Okay, so these are the basic things that you should be knowing it. This back propagation, let me tell you very clearly, generally we don't do it from scratch. When we use codes, when we use Python or any other language for neural networks, it has already been there. It's just that we have to know how this process works. If you know how this process works, you will be able to get a proper understanding of these advanced networks, that how they are different from each other. Because generally we are just advancing the architecture just to optimize it. Otherwise there is no need. Okay, so we say that in this architecture this is the major block, this is the major problem, so let's remove this block and do something else. So that something else will obviously affect this propagation as well. So how we are going to do is, look, so this is a simple question. Okay, so for this we are going to use x1, x2, x3, three inputs, h1, h2, single hidden layer is used. Look, when I am going to use this, it will be complicated if we increase the number of hidden layers. Okay, so I am giving you the most you can say naive example that you can have an idea, so that you can have an idea. And especially I choose an example where the output is not a single term but in multiple terms, just to give you a glimpse that how the things work. If it is in a single term, you can change the process for single output as well. Okay, so there are three neurons in input layer, there are two neurons in hidden layer, there are two neurons in output layer. So two neurons means it is multiple output. Multiple output means, let's say you have some problem which predicts two value, this is temperature and this is rainfall. You are getting two values, so it's more like a multi output neural network. Secondly, these are the connections which are fully connected. Look, this x1 is connected with h1 and h2. x2 is connected with both of these. x3 is connected with both of these. Similarly, this h1 and h2 is connected with both of these, o1 and o2. So it means that if you have three neurons here, two neurons here, then how many connections will be made here? Just let me know. How many connections?
Each one two connections, ma'am.
Sorry?
Each one two connections.
Yes,
Two
yes, each
connections,
one.
and next two connections. That means
Yes,
2 power 3, 8 connections.
I'm talking about only this layer.
Yeah, that's
Six
what.
connections.
So
Six.
3 into 2. If there are
Yeah,
m neurons and here there are n neurons, it means there will be m into n connections, correct?
yeah, yes, yes.
Right. So here there are 2 and 2, it means there are 4 connections. It's simple. It means that in between the layers, we have to set that how many neurons in the predecessor layer, how many neurons in the successor layer, so that m cross n will be the total number of connections. Why I'm saying connections? I can say m cross n weights. It's just like that. Okay, so this will have weight 1, let's say this is weight 2, this is weight 3, 4, 5, 6. So because some of the weights will be transferred with this particular input, so this connection I am saying as weights. So weights means this x beta. Okay, now one thing is left. You also say that, ma'am, there is another called beta node. Where is this beta node? So we say that for each of this successor neuron, there is some beta node. Okay, so for each successor node, there is a beta node. So we say that m cross n weights plus n beta node. So these many number of parameters we need to calculate for each layers, for each of the two layers. तो दो लेयर जैसी होंगी, m cross n weights होंगे, n आपके biases होंगे. It can be that you put the single bias for h1 and h2 also, but this is a special case. If I say you have to put a single bias for each neuron, not for each layer. We generally do that for each layer also, but by default, you can say the extreme cases are for each neuron. So these many number of parameters are there for two layers. So now you have to calculate the number of parameters between each layer so that I can have an idea. Look, just imagine if there are 100 neurons here, if there are 10 neurons here, how many number of parameters should be, right? So if we are using simple linear regression, the parameters will be same, right? We will be having multiple functions, multiple those, it will be very difficult for them. But for these are defined as such that these are optimized as such that it is able to handle so much functionality at one go. So that's why this neural network achieves so much success and it converts into a special subject of deep learning today. Okay, so let's move forward. So here are, I have defined those weights. So your problem is the input and target value of these problems are given. It means that x1, x2, x3 is given to you like this. The ground truth, the actual output should be like this. This is the target. What you will get from here will be O1 and O2. Here you can see the bias here is 0.5 for both H1 and H2. It is for layers, right? So there I told you it will be two biases. I am saying it can be one. It means that for the bias of H1 and bias of H2 is same. We can say that also. So ultimately, now we have defined some weights. So these weights are randomly initialized. For the first step, I just initialize these weights randomly. So basically, you can use any value here. You can use the value of 0 between 0 to 1. There are some special libraries also which can initialize weights in a proper manner. Okay, so there are some chiming weights, there are some another type of weights which say that these weights come from the distribution which will help your neural network to converge in a good way. So that's why you can use that also. But ultimately, these weights are in initial phase. It is completely random. Just that the restriction is it should be not very much big. So we try to put it in between 0 to 1. Okay. So this is your proper first step. So in the first step, we have to initialize weights. You have done. Second step is forward propagate, and I'm not going to show that. You have to give me an output that what will be the value here after submission. Just give me the value, put the value of x1, x2, x3, put the value of weights, just give me the value that what will be the output of submission here, because it's more like the combination here, the linear combination.
Ten point nine.
You are getting 10.9. Anyone getting another values? And for H2, what you are getting here?
फोर पॉइंट फाइव मैम
4.5. ओके ठीक है, देखते हैं आपका क्या range है.
The first one is 2 point something.
This is 2 point something. What is it? It is
2.6.
2.6. Let me check. I also don't know. So ultimately, just think about this. I'm talking about here, right? So this here. H1 is the final output after activation function. So one thing that I have to define here, activation function also. So for activation function, I am going to use sigmoid. Okay, so from out of this H1, what I have to do, we have to take the submission, put it in the activation function, and then the final output. So H1 means final output. So this submission, wherever I will use this submission, I will use Z for that. So it means ZH1, you are saying either it is 2.6 or 10.9. I have to check. Or 4.5 is for
फोर
ZH2.
पॉइंट थ्री फोर पॉइंट थ्री
Okay, let me check the values, what values I am getting. But what I want to tell you, the symbols that I am going to use, I am going to use ZH1 and ZH2. Z means just temporary output, right? Temporary, the combination, the linear combination only. H1 means after applying activation function. So you can see here what is ZH1. ZH1 is W1x1, W3x2, W5x3, B1. Okay, you have to add this also. Okay.
Sorry, I have not added that one also. It is coming 4.2 something. Let's see
Okay.
that.
Okay, let's see. Okay, so this is your first and second hidden layer z inputs, right? So the values will be, I am going to cross check it. After getting this value, I have to process it with sigmoid function, right? So what are the values? Let me see. Your first value is 4.3 and then your second value is 5.3. So what were other values? 1, 4, 5. It is 1. It is 4. It is 5. Okay. Here, what values you are matching up? 1 into 0.1. Let me erase all these things. Okay. This is 1. This is 4. And this is 5. Okay. 1 into 0.1, 0.1 plus. Then here it is 4 into 0.3, 1.2 plus. Here third is 5 into 0.5, 2.5,
1.5.
right? And this 1 into 0.5, 0.5. So how it is? 5, 5, 10, 12, 13. 1, 2, 3, 2, 3, 4. 4.3. So the here ZH1 is 4.3. Get it? Is it clear to you all?
Yes, ma'am.
All right. So similarly, we have to process ZH2. So it is coming as, I think, 5.3. Means you have to calculate. You can calculate it. Okay, take some 1 minute and calculate ZH1 and ZH2. It's easy. Hmm. All right. Okay, so now you have ZH1 and ZH2 with your hand. In your hand, you have to apply sigmoid function over these values. So sigmoid function, you already know it. So what is the sigmoid function? This 1 upon 1 minus e to the power minus x, right? Or is it plus? You can check it out. So on this activation function, you have to put the values of ZH1 and ZH2 in place of x, and you will get this value, this and this. Is that clear that how we are getting values from H1 and H2? Because these are not simple questions. Maybe I have chosen the question which has some complicated 0.1 or so. In your simple examination, there is a simple network can be given, some values of inputs. Inputs, I should not say, let's say some values of the previous layer, and the activation functions are given to you and weights are given to you. And the question is that what is the output from a particular neuron. So first take the linear combination, calculate its z value. I call the linear combination everywhere in this PPT as z. Okay, so this is the intermediate input, and apply the activation function, you will get the output. Is that clear to you? All right.
Yes, ma'am.
Okay, let's move forward. So now what I can say here, from this H1 you get some value 0.9 or something, from this H2 you get the value. Similarly, you calculate ZO1, ZO2, and finally the O1 and O2. Okay, just tell me one thing. Without calculating H1, can you calculate O1?
No.
No. So it means that that's why you need this progression, forward progression in full steps. It means you have to first calculate H1 and H2, then only you can calculate O1. It's not like that you can jump any layer around. Okay. So if your question is calculate the value of O1, it means first you have to calculate H1 and H2. It is understandable. It is by default setting. So it's not any other way around. So you have to first calculate the full layer, and from which the question is arising, from which neuron you can get the value out of there. So this is your forward pass. Generally, forward pass is easy. You all can do it. It's not the matter ki, you can't. You have to just do the linear combination and put it in the activation function as given. Sometimes activation functions are very simple as well. Sometimes the activation function is x square. So what you have to do, the zh1 is 4.3. So activation, after applying activation function, the value will be 4.3 square. Simple. So in your examination, what is the activation function? This is important. Okay. I have chosen the more complicated activation functions because you can see how to calculate it as well. Okay. So forward pass is easy. First step is you initialize the weight. Second step is forward propagate. So after forward propagating, you can have an output from node H1, H2, O1 and O2. Simple. Okay. Now think about this. Your target are 0.1 and 0.05. So it means that this value should be 0.1 and this value should be 0.05. It is somehow very different, right? So it means that the initialization of your weights are not good. If it is not good, you have to update them using this error. So how to define error? Step 3 is define error. So the formula of error is 1 by 2 summation of OI minus TI square. Okay, so there are two outputs. That's why O1 minus T1 square, O2 minus T2 square. Sometimes we confuse that whether it is T1 minus O1 or O minus T. Okay, it doesn't matter because after calculation you get the same results. But question is this, when you apply this formula, it is easy. When you apply the formula other way around, you somehow do mistakes in processing. So if it is convenient for you, you can simply write true minus false. Yani wait a minute. Sorry, false minus true. It means this is your false value. This is your true values. Okay. So in this way, you can use it false minus true. You can remember it like this. Otherwise, if you will use other way around, t minus o, it will also give you the same results. But generally, students get confused. They drop one minus sign, and that's why their result is different. Okay. Choice is yours. It's okay. You can try it for the other way around also. So step 3 is get the error. So error is simple. You have to define the error. That's it. Okay. Now we start using derivatives. Okay. So in this step, let me tell you the objective. What I want. I want to update W1. Question sometimes is asked like that. This is the network given to you. The input are this. The target are this. The initial weights are given to you as this. Now tell me how to update weight 1 or how to update weight 11. How to update bias 2. So this can be the question as well. So to update the weights, there is a formula. Okay, we will use the same formula here. This formula. So it means that the weight that you want to update, this is a new weight, is equal to old weight minus neta or alpha, what you can use here. Neta means your learning rate and the gradient. Okay, so ultimately this weight is given to you because initialization of network is given to you. What we don't know this. So we have to derivate the error with respect to each and every weight. Question arises is this. How to calculate is, it's a very simple process. If you will see here, I mean, generally students get confused here. They make the wrong predictions, they make the wrong calculations. But if you will see the concept, it will be very easy for you using the network. How? I will show you here. Okay. So ultimately, what I need my main objective is I want dE by dwi, and I is here for me 1 to 10. There are 10 weights, right? 6 here, 4 here. So there are 10 weights. For each weight I want to derive this formula dE by dwi, nothing else. So but this formula derivation takes some time. So now please focus here so that you will not get confused. Okay, now just see this network. Okay, so why it is called as back propagation? Because it first start with updating the weights from this layer, then it update the weights from this layer. So it means it starts updating the weights from the back. That's why it is also called as back propagation. Okay, so just think about this. I have some function e, okay, e, and it is defined as 1 by 2 O1 minus T1 square plus O2 minus T2 square. Okay, you have to give me the answer. If I have to derivate it with respect to W, let's say last weight 10. Okay, so what I have to do, I have to derivate all this formula with respect to 10. So can you give me the answer? What can be the derivation from this scenario which is just on your screen? You know the derivations, right? Can
Be
anyone
out 201 D DO1 by DW because T1 will be constant.
Okay, you know the concept, that's why you were saying. Those who don't know anything about this concept, just think about this. Here it is O1, it is T1, this is O2 and T2. There is no W10, right? If there is
Yes,
no
it is
This should
it
be
is
W10,
zero, ma'am.
zero anyways, right?
It will be zero.
right. But it is not zero. Why? Because it's of a function of a function. Let me give you an example. So this O1 can be written as neta of ZO1 minus T1 square plus similarly neta of ZO2 minus T2 square. Can I write like this? अभी इसको हटा
Yeah,
दो.
yeah.
Right? So it means that I opened this O1 in terms of ZO1. I opened the O2 with in terms of ZO2. Now this ZO2 is the combination of H1, maybe W7 plus H2, maybe W9 plus bias 2. This Z is H1 W8 plus H2 W10 plus bias 2. If I am not wrong, let me see. H1 W7, H2 W9, correct. Right. So now I can replace this ZO1 with this formulation. Now it has W10. Right. So it means that this term don't have W10, we can ignore it. But this term has W10. Now we have to take derivative here. Correct? Can you see that? Can you see that? Is this
Yes,
clear?
ma'am.
ठीक है. So generally when this happens, when you introduce, when you have some terms with respect to another functions, we use the rule of chain derivatives. So what we say that, look, here it is written that E is a function of O1 and O2. O1 is a function of ZO1. ZO1 is a function of W9, W7 and W9. B भी लिख सकते हो आप. So in this way, if I want to derivate E with respect to W9, let's say dE by dW9, what I will do, I will first take the derivative in terms of O1 into, take the derivative of O1 into with ZO1, multiply derivative of Z01 with respect to W9. So look here, let me correct it like this. So dE over dW9 is equal to dE dO1 into dO1 dZ01 into dZ01 dW9. So you can see this can be cancel out and this can be the value, right? So this is called chain of derivatives. So to calculate this, because we cannot calculate is by looking at the screen all at once, what we say that we divide it into multiple functions. So now because E is a function of O1, we can derivate it with respect to O1. O1 is a function of Z01, we can derivate it with respect to Z01. And Z01 is a function of W9 ultimately, so we can use this as the third chain rule. Getting this point? Is it clear?
Yes,
Are you
yes.
Yes,
okay?
ma'am.
So now you will say, ma'am, there is a possibility that E is a function of O1 and O2. Why we have just chosen O1? No, we have not just chosen O1. We generally put the full formula like this. So dE by dO2 into dO2 by dZO2 into dZO2 by dW9, because this is 0. That's why this whole terms is negligible. That's why we don't write it. Okay, so it means that if E is a function of 2 or 3 variables, it's okay. Take the summation of each and every. Okay, so this is how you can see the complicated complex structure of this back propagation thing. Okay, so because
Hello.
it's
Good, af- good afternoon, madam.
yes.
Project guide, amma.
Okay, so this is how we apply this chain rule here. So this chain rule we are going to apply here in our system as well. So just see here, this is done, this is done. So here what we were defining, dE by dO1. So first calculate the derivative of dE by dO1. So when you calculate this derivative, this will be negligible term and you will calculate it as O1 minus T1. Similarly dE by O2, O2 minus T2. You know the value of O1 and T1 now. You can put it here and calculate the value in terms. O1 is this 0.8896 minus 0.1.
Ma'am,
This, yes.
here activation energy will be specified in the question.
Yes, it will be
Like it will.
given.
Oh,
It will be
okay,
given.
okay.
So it means that look, I use this term na, dE by dO1 is it's okay, but dO1 by ZO1 is dependent on this activation function now, right? So next term when you are going to use that, what you have used, dE by dO1. This is good. It's okay. Now dO1 by dZO1. dO1, what is O1? O1 is neta of ZO1, right? For our case, I have used here neta. So this neta is sigmoid. If it is not sigmoid, it is maybe simple x square also. So if it is simple Z01 square, the derivation will be 2 of Z01. It's simple. So it means that this term here, this term is related to activation function. It's more like that. So here I have also included this the activation of sigmoid function. So ultimately what you have to do for this step, you have to derivate the sigmoid function with respect to x here. So this x is replaced by Z01, ZH1, ZH2, whatever you are using, right? So for this, maybe I can upload it. Okay, any question? Yeah, sure. This session is being recorded and it will be available later.
Let's, I don't mind, for like in an exam, they won't ask us to calculate it with the sigmoid function, right?
Generally, look, who has asked the question? Who asked the question?
I answer.
Gaurav, right?
Yes.
Okay, Gaurav, what happens now? If you find the sigmoid function, the derivation of sigmoid function is simple as this. So this is your sigmoid, 1 minus sigmoid. So that's why I choose this function. Generally in our means, I don't know about your NPTEL, but here when we derivate it, na, it comes through this derivation, that the derivation of a sigmoid function is simply this term, which is easy. If you know it, it will be easy for you to apply. It does not need anything. Sometimes what happens is, the question is like that, ki these are the values of your activation function as well. They give you, let me give you the scenario. Okay, why I'm telling you this, because you can't read the mind of the paper setter, right? Maybe if I am in a good mood and I'm like, "Ki, okay, I have taught so much well for this back propagation thing, let me ask some questions, it will be easy for the students because I have taught you." So what I will do, I will have this layer. Okay, this is let's say h1, h2, h3, and this is your o1 and o2. What I will give to you, I will say, I will give you the value of h1, it means which is having sigmoid, maybe let's say zh1. Okay, so this value I gave to you, I give to you, I'm not asking you to solve it. h2 I give to you, this is like zh2. Okay, this value is already given. h3 is already given to you, so this is also zh3. This is given to you. Third values are, these three values are given. This one is also given to you. Let's say zh1, zh2, zh3, this is also given to you. Now I give you the targets and I ask you that I have this system with weight 1, weight 2, can you apply it, and using this sigmoid function can you update the weights of this particular way? Then it's okay, not a problem, because you know that the derivation of a sigmoid function is nothing, it's just like 1 minus, means this is given here, right? So this is a simple derivation. So it looks like that if you properly derivate it, you come to this point. Before that, because you don't know, it has some 5, 6, 7 steps, I can understand, but now you know about it. So let alone these derivations, you have the deductions and you know this deduction. So for example, if I ask you that what is the derivation of you can say sin x, do you know the derivation of sin x?
Cos X.
Minus cos x.
Right, so you know it. So do you know the full process or full derivation to get this derivation of from sin x to cos x? No, you don't remember, right? Even I don't remember. Even maybe हो सकता है कि मैंने कभी उसको सही से पढ़ा भी ना हो, right? So here these deductions are important. So when you are going through towards some lectures or so, make these deductions, write it somewhere, so that when you are going towards your examination, read those deductions at the end. That can help you sometimes. Okay, so for your perspective, because you are going towards this sigmoid is a big function, it is complicated, yes, but from my perspective, because I am giving you this formula, final deductions formula observations, if I let you see that, then I can ask. Okay, so I can't say that it is complicated. Getting my point?
Yes.
So generally, I always tell this to my students, that when I am going to set the paper, I can get an idea that how much you know. I can't let you have the questions that can take 1 or 2 hours, but I can give you those conditions in hand in the question itself. So if you say that because this question is complicated, let's leave this question, it will not come in exam, but it can come to your exam by given conditions. I can give you as many as conditions that I can have in my hand. So now give the final step, but you, because you leave this topic, you have not gone through कि अच्छा अगर इतने भी हमें दे दिया होता, so final step ही तो निकालना है और तो कुछ नहीं करना ही नहीं है. So that's why work in this culture. Okay, so yeah, coming back to this point, so for getting this derivation, maybe I have uploaded some document, I don't know, I have to see that, but this is your homework, that from this to this, get it out. Okay, so it's a simple derivation rule, nothing more. You are using simple, the basic derivation rules, but you get this equation in this form. Now you have the left hand side, you have the right hand side, just process either from the forward way or the backward way. take out some middle steps, and finally deduce this. This is the final deduction which is true. Now you have the problem that how you will deduce it. So this is your homework for you. Please do it. I am not going to upload this document right here in this week, but I will sure upload the document after this week. So I am giving you this week that please explore this. It's very simple. It's not tough. Try it at least once, that how you can deduce this. The derivation of a sigmoid is in the form sigmoid 1 minus sigmoid. So just look like that. This sigmoid function is looking like a probabilistic function, right? So the final derivation is more like success probability into failure probability, if sigmoid is a probability, right? So abstract form mein this is the main deduction, but from mathematical point of view, at least do some rough work on paper and pen. Okay, so mainly it's more like that. This is very simple to go because the error functions are defined in a very simple way, in a mean square way, not a very big functions. The second question is this O1 or Z01. It means it is talking about strictly about activation functions. Generally, here when we have given some examinations, generally we got the functions like x square, x cube, or let's say sin x or something. Easy functions. We got these easy functions, but one time we also get this like this is the sigmoid function, the values are written like that, and you can calculate it. Or even don't calculate it because you are going to have your online exams. Even in the written exams, we can give you this question, just write in the form of equations as well. No worries for that. So that's why we motivate you to go for the whole process. Okay. Now we have to calculate the last thing, that is that Z01 with respect to the weight that you want to have. Okay, so let's have this first. Okay, see here. We have two types of layers. So what we were having, we have this network 3, right? This is 2 and this is 2. Here weights are W1 to W6. Here weights are W7 to W10. So first we will update these weights. Okay. So for these weights updation, what we will do, we will be first calculating simply E over O, whether it is O1 or O2, then this O over ZO, whether it is O1 and O2, then dz of O with respect to the particular weight, whether it is W7, W8, W9 or W10. So this, for this case, you can simply use the equation because it's a linear combination. So let's say it can be like H1 W7 plus H2 W9 plus B,
Ma'am,
right?
can you repeat this one?
Which one?
The derivative of E with respect to O1. Then you have said derivative of O1 with respect to Z naught, right?
Right, wait a minute, give me a minute, okay? Do you have any classes? Oh, okay, all right. Where I was, okay, here. Let me get it again. I don't get your question. Can you please repeat?
Ma'am, please repeat from the derivative of E with respect to
This
O1.
one? Here, from here?
Yes.
Okay, so
Yes,
just
ma'am.
look at, okay, just look like this. Let me again write. Look, here this is your input, this is your hidden layer, this is your output. Okay, here there are 6 weights from our example W1 to W6. Here there are 4 weights W7 to W10. So first what I will do, I will update these weights. So for to update these weights, I have to calculate dE by dW. So this W is ranging from 7 to 10. Okay, so to calculate this, what we have to do, we have to go stepwise step. So for first step, I will calculate dE by dO, whether it is 1 or 2, it can be anything. Okay, first thing. Second multiplication will be DO, whether it is 1 or 2, with respect to DZO, 1 or 2. Is it clear now? Who has asked the question?
Yes, 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 ma'am. Yeah.
Okay, so with this DZO1 or O2, we will be going with DW, whether 7 to 10. So just get through this equation. If you have this equation, ZO1 is H1W7 plus H2W9 plus B2, and if I have to calculate DZO1 over DW7, what it will give?
H1.
H1. Perfect. So if I ask you what is the value of DO1, DW9, what it will give?
H2.
H2. Very good. So it means that you can simply apply this. So first is, we have seen what is the formula of E. Now calculate with respect, derivative with respect to O. Second, we see with respect to O, for calculating the derivative of O with respect to ZO, it means you use the activation function. Third, we see with respect to ZO, for the weights, you have to use these equations. So it means that you just have to follow by calm mind that what is the formula of this function. That's it. You should be knowing that. If you know the formula of function, you can easily derive it. So here also what we have done, look here. So we are first applying the weights updation for 7 to 10. Okay. So look here. For weight 7, DE by DO1, DO1 by ZO1, ZO1 by W7. You get the value of DE by O1 as O1 minus T1. This is what you have get from the function, because our function we have just calculated it. For O1 Z01, it is more like, it is same like, it is like this. It was this. So Z01 is simply just O1. So you can see this thing here. And last is, you told me that Z01 with respect to W7 is H1. So these three terms are multiplied with each other. You know the value of O1, you know the value of T1, you know the value of H1. Put it there. This is your final value. If it is, you are having any doubt in these equations, then let me know. Just see it for 1 minute or 2 minutes. Get digested that if we are going to calculate, our motive is to calculate the derivation of E with respect to W7. Okay, for that we divide it into three parts. First is with respect to O1, with respect to Z01, then with respect to W7. So with respect to O1, it's simply O1 minus T1. With respect to Z01, it is because of sigmoid function, it is sigmoid 1 minus sigmoid. And with respect to W7, it is simply H1. Now multiply these, you have the values, you have calculated it beforehand, put the values here, you will have the answer of DE by DW7. So to update the value of W7, what you will do, W7 value will be old W7, which was the value of old W7, 0.7. 0.7 minus neta value, let's say it is neta, and you have to put 0.0765. So this is your new W7. Is that clear to you? Any doubt here?
Yes, ma'am.
Okay. Will it possible to provide practice numerical question? You can have the question. You have much more channels. You can have much more on your internet. You can use GPTs as well to create a question for you. Okay, so this can, you people can do at your own end. If you have some question you want to access ki whether it is correct or not, you can pass me that question with solved, properly solved ki ma'am it is correct or not. I can do that only. Okay, because if I am going to give you some questions, you are going to restrict yourself with those questions, and you will be like ki, ma'am has given this question, so these are going to come in the exam only. So that's why I am giving you some samples. Find out the samples all over the internet. All right. So similarly, I think you can calculate the values of for W8, W9 and W10. It will be easy. Okay. So these are written here as well. So this is your first layer. Okay. Now I want to highlight something when going towards the next layer. Okay. So now you are going towards B2 is also here. So you can look here. You have four weights W7, W8, W9 and W10. You have B2 bias also. So you have to take the derivative with respect to B2 as well. Now we have the error terms, right? So those error terms are O1 and O2 with respect to O1 and O2, and W7 is only connected with O1, not O2. So that's why we are considered its effect in calculation, because I told you previously that we include that, but it will be nullified, it will be 0. Here you can see for B2, because O1 and O2 both comes for this B2 calculation, so that's why we are using this plus symbol. So we will be calculating B2 with respect to O1, B2 with respect to O2 and take the addition. Okay, so this is how you can get the values of first layer. Now the derivatives of the next layer. For the next layer you have to pass from H1, right? So it means that think this network here. So it means that we have this x1, x2, x3. This is your h1, this is your h2, this is your o1, this is your o2. Okay, to calculate the weights here we have E, and we started with O1 and then derived here. Okay, but to calculate the weights here, because these weights are connected with H1, not directly with O1. So what we will replace, we will do the same processing but with respect to H1. So we will define E over H1. But to calculate this, we have to use O1 and O2. Getting my point? So if you will going towards the farther layers, obviously the processing will be same, but it will be complicated. It will be containing more calculations. So what you will do, for this step, okay, we have calculated for this step. Now we are at this step. For this step, O1 is replaced by H1. It's okay, we calculate dE by H1. So the formula will be like, for this weight W1, what we will do? dE by dH1, dH1 by dZH1, dZH1 by dW1. It's simple, same as we have calculated here W7. It's a similar way. But question is, how you will calculate this dE by H1? You will calculate dE by H1 with this. So dE by dO1 into dO1 by dZO1 into dZO1 by dH1 plus dE by dO2, because O2 is also connected with H1, dO2 with dZO2 and dZO2 with dH1. Getting my point? Are you getting how the system of equations are getting complex and complex? Yes or no?
Finally, H2 or H1, ma'am?
I'm talking
DZ O2
I'm talking about W1. W1 is connected with H1. That's why I'm not included H2. But for maybe here other weights, we will include H2 also. You can calculate H2 also, okay? It's just that final weights will be 0, maybe.
It's okay.
Some relation between O1, H1, and X1, they are given.
Sorry? Equation?
Relation between O1 and H1, these are given.
Yes, what is O1? O1 is neta of ZO1, right? Correct?
Yes,
And
yes.
ZO1 is H1 W7 plus
Okay, that one
H2
only. That one
W9
only.
plus B.
Okay.
So okay, right? So it means that we are using these set of equations. So just tell me, I am using some weights which has floating points value, means 0.1, 0.5, and you get the value of w7 or something in some pointers, in points, in decimal points, and you are multiplying all this. So can you say that the weights which we are updating, यहाँ जो आपकी वैल्यूज होंगी, द वैल्यूज हेयर इन डेसिमल पॉइंट्स actually can be larger than the values that we are going to calculate here. It means as we go deeper and deeper, the updation of these weights will converge to zero if there are, let's say, 30-40 layers.
Ma'am,
Hmm.
hello.
Yes. Yes, yes, yes.
Ma'am, at the end of this session, or at the end of this concept, when you're done explaining this the concept, can you please explain us that how does it really work? How does this concept of back propagation, forward propagation, or the concept that we are learning right now, how does it help the AI to think?
Okay, okay. Let me tell you this after just this calculation.
Yeah,
Okay.
yeah, sure, ma'am. I'm
Okay.
sorry if I interrupted you.
No, 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 no. It's not a problem. Obviously, you should be knowing if you are here doing some mathematical calculation. You should be knowing that how this calculation will actually benefiting you. Otherwise,
Hmm.
there's no need for that, right? So
Yes,
if you
correct.
have some motivation, you will have a clear mind that how we are proceeding with these steps. That's why I tell you in the starting also that open your mind, see it very clearly how steps are going. These are more like the flow should be very smooth. It should not be like ki,
Hmm.
okay, first we have to do this, second no, you don't have to remember the steps. I don't remember the steps right now. I know how these are working, right? Okay, let's get into that again. What we were discussing is this concept clear that how we are calculating these gradients can affect the next layer or next layer or next layer, yes or no? Okay, if there is any question, then please go ahead at this step. Because here now, if first we have evaluated the weights or gradients with respect to the last layer, W7 till W10 and the bias 2. Now we will change the weights of W1 to W6 for and bias 1. Okay, so for that I have written here with respect to H1. And for H1, I have written the same equation using the same rules that we have devised right now. Just that these equations, if the last layer is there, the equations will be 3. If the second last layer, these equations will be multiplied by the number of output units. If more output units are going to be here, it means more calculations will be there. The concept is same, concept is not different. Okay, so finally what you will do, you will have all these values. You can go towards this PPT as well, and finally you can update the weights because you now have these parameters, and after updating the weights, your new weights are like this. Maybe you get some very minute changes, but this happens in this derivation. Okay, so now your system is the same thing, inputs are same, targets are same, the function, activation function, given function is same, but for the next iteration we will use these updated weights. Now we will again calculate output, again calculate error, and revise this system again and again and again. Till then the error is converging to 0 because this is the minima of the error, right? So this is why this back propagation work also. So if you have any question, then please ask me related these calculation. Then I will tell you that how it is benefiting in your actual real world system.
Just to question. First, we take the summation of all weights. Then we take the outputs with those weights which are completely random. Then we take the derivation, and that entire thing is front propagation. Then we take a derivation, and then we back propagate. Is that's what it is, right?
Yes, in forward propagation there is no derivation. You calculate combination, then you calculate activation function, then you proceed further till the end of the layer. You get the output. Okay, After getting output, you calculate errors. Using error, you calculate derivations and back propagate it and update the weights. Is it clear?
Okay, and then again back to forward propagation. See.
Yes, yes, yes. Generally, we don't ask for multiple steps in writing these questions. For written examination, we don't ask for more steps because it is not easy. But yes, computers are powerful, they can do that. Okay, is it clear?
Ma'am,
Hmm.
this new bits will have zero error or will have error?
No, it will have error also. Just think about this. You are coming to the first class of your machine learning. You don't know anything about it. You are just here with some conception. Oh, ChatGPT works like that. Oh, these softwares are working like that. Oh, these big navigation systems are working. You have this abstract idea only. Now, when we are just coming into basics, you get to know some amount of knowledge that okay, maybe the system can work like that. Okay, after coming each and every day, you improve yourself. So this is how weights are also improving.
Okay, ma'am.
Okay, so now let me tell you how this work for you in the real life application. So just think about this. This is a mathematical model. Okay, so how mathematics work is, mathematics don't know anything whether you are giving a image, a text, video, audio, which type of data, whether it is weather related, whether it is crop related, whether it is your student data. It does not know anything. It just know कि I have a number 10. This number 10 can be a age of a person, can be the leaf count, can be student marks, it can be anything. And the output is number 5. That 5 can be anything as well. It does not know anything. So what we do, we think the problem in a more abstract way, not in an application way. So we are thinking it is, there is some input x, it can have any values. There is a output t, that can have any values. Obviously this combination is given to you because we have some scenarios, right? So we are restricting our space. We are not saying we are making infinite combinations. No, we are making, giving you some restrictions. So what we are saying, this is your input x, this is your output o. Okay, in our system there can be multiple x, there can be multiple o. For example, there can be multiple properties of a student. Let's say your marks of different subjects. So it means you have multiple inputs, and I want to find out whether this student is eligible for a mathematics olympiad. Means if I can choose that person for a mathematics olympiad, and साथ में ही let's say the other output that I want to get is कि whether this person needs training or not. Okay, it's a simple output. I want two outputs. So these two outputs will have some values. Okay. So ultimately, machine don't know about Olympiad marks and anything. What I am going to say for a mathematical point of view, there is some input x1, x2, xn. There is some output o1, o2, op maybe. And I want to map from input to output. It's a simple thing. So whenever we are going to use this deep learning, we call them as big functions. Let's say this is a model which takes input, which gives you some taking some input x, you get some input y. Okay, using some parameters theta. Those theta or weights that we are updating, right, we don't know because this can be random, this can be anything. We don't know the exact function that it can map. Actual true model, we don't know it. We are just predicting it. We are getting closer towards those functions that can give me that output if I give this x. So how will I say that? If I give you, let's say if I give you the student data of x1, I get y1. If I give you the data of x2, I will get y2. Okay, similarly most of the cases. So I will update my system. Till then I am getting the good results, I am getting the outputs which are nearly equal to y, right? For that, there are simple ways. So first person say that the mathematics is a very complex subject, and you know many thing about mathematics. Define a proper optimization problem and do that. But optimization problem needs some prerequisites. the function should be in convex form, or many multiple restrictions are there. If the function in this form, apply this rule. If the function is this form, apply this rule. So for our functions, for our these scenarios, the functions are completely random. The functions are non-linear. The functions are complex. So we are not able to grasp which technique to apply. So they say that if you don't know anything, we just update the system step step so that we can converge towards the true value. I'm not saying I will get the true. I will not get the true. I will converge towards that. So when this convergence or leading towards a step by step function, you need to update the wrong weights that you have started with. Maybe let's say, that's why I give you an example. Maybe you have a wrong perception when you have started this class, but when you are trying to listening that what is happening, okay, this is, you are validating, it means you are changing your concepts in your mind. Your concepts are changing automatically, subconsciously, you don't even know. But for, just think about a system, उसके पास subconscious जैसे, it's nothing subconscious. It's more like, look, what he will say to you, the system say, today my parameter value is 235. Do you want to use that, or you want to update it? If you want to update it, what will in place of 2, what will in place of 5, what will in place of 3? So you will say there is a mechanism, wait, decrease or increase it with some, you know, the deviations. So those deviations are coming from the derivatives from the errors. So that's why we are calculating this dE by dW. So these deviations, we are saying ki this much error is in your system, update the weights so that we can remove this error. So if you think it can remove the error in from one step, no, it will leads multiple step, right? So who has asked the question? Am I able to answer that, or you want it in some another way, please?
No, ma'am, you have answered it very proficiently, and thank you so much for considering my question. Ma'am, another question that I have is like we there is a lot of buzz around. Firstly, can I let me take the permission to ask you that can we ask the questions regarding what's happening in the AI right now, current affairs?
Can we take this question at the end of the class? I think 10 minutes are left, then we can take. Otherwise, I just go on with the another topic that we have in this week. We can take your question after 10-15 minutes. Is it fine?
Yeah, sure, sure, ma'am.
Okay, okay, okay. So I think now this back propagation thing is uh, clear to you, right? So basically, this you can now get it. Generally, look, from my experience, it's more like that. If I everything is given you in your videos, it means, or I should say, sir has given the most appropriate explanation of every terms and things, right? I have just repeating some of the things where I can say that ki you people has some difficulty to understand or take some time. So that's why I have chosen those subtopics from that. In this neural network thing, you all know how to calculate these things. Forward pass is very clear, much clear with I think 80 to 90% of you that are present right now. Problem is we always get these terms, back propagation, gradient descent, we take it as the black boxes. It means it is doing something, it's okay. What I wanted to tell you from this class is this is how the functioning is done. If you want to be in this field, okay, for neural networks and all these field, you should be knowing that how these things works. If you don't know about these things, many of the beautiful concepts, you will be unknown from that. So other theoretical things, I think this ppt will be given to you. You are able to get it from these ppts. So I'm not going to go towards those things which are already known to you, or you can read it, okay? So I'm just jumping towards another topic which is very much explained in logistic regression, but I want to highlight something, okay? So basically what we are doing is, from the neural network perspective, that we have some data and we want to calculate the parameters theta ultimately. So this is written, okay? So we wanted to calculate what is the probability of theta given x, or sometimes you can have d also, capital D, capital D also represent data, capital X also represent data. Okay, so this is what I want to maximize. This is maximize. So which, because why? Because this is given to me, this X is given to me, and I am calculating this, I am predicting this theta. So the probability for which theta this is maximum, I will choose that. Just think about this concept, because all of these are probabilistic models. So what I wanted from this data, I want to calculate theta such that these thetas has the maximum probability from all the thetas. I don't know how many infinite combination of thetas will be there. Okay, so it is very difficult to calculate, because neither we know those probability distribution, nor we know anything about theta. We don't know from which spaces it is coming. So we say that this is a conditional probability which is explained by Bayes rule. So I can just use the Bayes rule to expand this. So to expand this, I can use this rule. Okay, so this is called, this probability on the left hand side, it is called maximum posterior probability. It means it is MAP. Or you can say, why I'm saying maximum, because I want to find maximum. Otherwise it is called posterior probability. Posterior means after calculation final probability. Okay, now coming towards the right hand side, just think about it. If I want to maximize this, can I say, if I maximize the numerator and constant denominator is there, I can remove this denominator? Listen again. I want to maximize this left hand side, and right hand side has some numerator and denominator. This denominator is fixed. It is fixed. Okay. We don't know the value, but we know that it is fixed. It is constant. So can we say that to maximize the left hand side, I can only use the maximization of numerator on the right hand side? Yes or no?
Yes, ma'am.
Okay. So it
Because
means
anyway,
that,
system is constant.
yeah, that's why I remove this. I will not use this. I will use only these two terms. So first term is this x given theta, and another term is px. So look, here it is theta given x, means data is given to you and you are calculating theta, but here it is written as theta is given to you and you are calculating the probability of x. So just think about this. Let's say मैं आपसे पूछती हूँ, I have given you some food, okay, some variety of food, and I want to calculate the probability for one of your student that which food, yeah, which parameter that he will like or not. Okay, how much marks it will give, right? So it can give me multiple marks or something. Generally this Bayes rule follows that if we don't know this posterior, we can oppose it. We can, मैं इसको उल्टा कर देती हूँ, because the another way around I have something in my mind. So it means that given some theta, I calculate the probability of x. This I can do. I can simply, because what you were saying, you were initializing some theta with your random initialization, and you are again and again updating it. It means you have some initial value, calculate x, you have next value, again calculate x, you have next value, again calculate x. It means you are using this equation for iterations. It's okay, it can work. So basically this term is called as likelihood. Okay, this is called maximum likelihood probability, which we have discussed in your logistic regression class as well. Okay, so how to calculate it, I'm not going to explain it right now. It's not too much time we have, but it's written in this PPT as well. Second thing is this px. If I don't use this px, it's okay. This is called prior. So what I am saying, just look like this. The posterior probability is dependent on likelihood and prior. Okay, if we don't know prior, we have only likelihood. So what we are saying is, if I want to calculate this posterior probability, I am using only likelihood. Remove prior at this stage, because those are in multiplication, right? So if I want to maximize this posterior, I want to maximize the likelihood. So what I am saying, I want to maximize the likelihood. It's okay. But sometimes likelihood alone is not sufficient. Okay, we have some prior information as well. Let's say if I'm giving you some food items and asking you some question based on that, let's say you have some knowledge about those food items. So this is called prior. So if I include that prior knowledge here, it would be better. I'm not saying this likelihood will not work, but I'm saying if you include the prior, it will work better. So you are imposing conditions on the basis of this prior. Imposing condition in deep learning, in machine learning, you can say as regularization. So it means that if I am not using prior, simple likelihood I am using, you will get some answers. You will get some probability. It is good enough. I am not saying it will not converge, it will not do anything. But if you are using prior, it means you are putting regularization. You are considering overfitting. Using simple likelihood, maybe the system get overfitted. But using prior, you can remove or reduce the possibility of that overfitting. So first thing is, likelihood is very important to calculate this posterior. Second thing, posterior probability is regularized with the help of prior. So if you are using prior, it is more putting conditions on the system. Okay, is that clear? These three terms: posterior, likelihood, and your priors.
Ma'am, is the goal of this
Sorry, मैंने
topic is
गड़बड़
all
लिखा है.
about reducing the parameters?
The goal of the topic is about how to formulate problem. How to formulate, whether you should look, when you are working in this regression na, it will be easy for calculating errors or something. This error is simply what we have seen in an exam, in the example right now. It is a part of your regression problem, but classification don't work like that. Do we have the classification in the same form, minus error or something? No, we have seen the classification form in the form of log likelihood. Remember, you have used an
Yes,
px, right? So that's why
yes,
this
ma'am.
likelihood estimation is also integrated here, because it is easy to give you an idea with the help of regression problem how things are propagating, but it will not work directly for classification. You have to adapt the system based on this likelihood estimation. Thing is, means things will be propagating in the same way, but the estimation of parameters will be different. The error is calculated in a different way. Here the error is more like which you have right now used, o minus t, but in classification you can't use that. The error will be like o log t, sorry, t log o. Remember, sorry, you calculate error in this form. This is your binary cross entropy or something, where you have learnt in logistic regression, जहाँ आपने log error लिया था, right? So now your
Yes,
errors are
ma'am.
different. So how to calculate error is based on the problem of classification or regression. So that's why these things are just included to get an idea how to classify data. Okay,
Yes,
any more
ma'am.
questions? So this is more like these things are repeating in many slides maybe, so you can have an idea. You can read it out. If you have any doubts, you can email me for these sessions, because it's not possible for me to converge all the things in 2 hours. And we will be having some extra session after these 12 weeks as well. So I generally try to cover those topics which I have not covered here there on the basis of your requirement. So that's why I float that form. So you can put that ki these topics are need to be revised, then I can only cover. Means 2 hours are not enough to get through all these topics in detail. Means frankly it is not. So let me very tell you very frankly, these topics when we get to learn from our professors in IIT, this back propagation or something, it takes at least 2 to 3 days. So means 2 to 3 lectures, I means you can say कि they are giving us too much examples, and then one question, then the relation with the real world, then we have some assignments. So it's a big process. It's not like that we are going to have this discussion in the 2 hours and end it up right here. Okay, so just go through this, and if you have any questions, then please you are most welcome. And आपको जिसको एक question था, I don't remember the name, who has asked, in the last we can take that question, but before, if you have some question related to this specifically topic, then please first you go ahead. And yes, My and one more thing to announce that this this feedback form is for me only. It is not going in the NPTEL sessions. Those are different. So the main objective of this feedback form, that you what you want, how you want to take up the next sessions, what topic you want. So basically this is the main motive for me to get the feedback from you, in the sense that I can improve, or what are your requirements. Okay, so believe, or I suppose, that if you are filling this form, fill in the zone that how your sessions you want from the next week or next topics to be covered in. Means, let's say ki this topic needs more numerical, you can write. I am not saying I will be applying all of it what you are saying, because it's not easy. You are here 40-50 people, I can't meet all your 40-50 people demands, right? So but I can have an idea that the majority of the students are more like that, so I can put it in this way. Because what I am getting the feedback, it's more like you are thinking that you are giving the feedback to the NPTEL portal. For me, so it is not, I'm so sorry. It's a separate form that is on your portal. This is for me only. Okay, all right. So thank you so much. This is for the session today, and if you have some doubts, then please go ahead.
Yes, ma'am.
Hmm.
Ma'am, we have in recent days, or since in recent weeks rather, we have there is a lot of buzz regarding artificial general intelligence. Uh, so, like you said that, a user's prompt would be like, which is quantized into uh, mathematical stuff. So, when we talk about artificial general intelligence, so does it mean that the prompt or uh, the mathematical calculations would have infinite weights and infinite calculations?
No, no, no. Look, artificial general intelligence comes here where, look, may I know your background so that I can able to use those terms? Means, if you are comfortable with these, what are you doing right now?
I'm in my second year of artificial intelligence and data science engineering, but I'm from a very remote college.
No, it's okay.
It's
BTech,
yeah,
undergraduate, right?
yeah, right.
Okay, okay, so okay. So it means that have you have any experience in running codes with data, or somehow in data science?
Not much.
Not much. Okay, have some ideas, small, small, right? Small idea, right? Just, okay, just
What
think
about?
about this in this way. You are a human. You are just a second year student. Okay, just think about this. If I tell you about fruits, only fruits. Okay, in the fruits, I have given you a restriction over, let's say I have, because I don't have infinite number of fruits in my hand, I can still show you some 10 or 15 type of fruits that are present around me. Okay, okay, look, these are the fruits and these are look like that. Maybe you have eaten something, so you're able to have that knowledge, right? As a human, but human has the most adaptive mind. At the instance where you will see a different type of fruit, you will ask someone, okay, okay, what is this? I have not eaten this. Oh, it's a jackfruit, or it means it's a dragon fruit. I have not eaten it. Okay, you get an idea because you have someone to speak. For models like that, what happens is, if you have trained a model of a fruit classification, I'm giving a very simple problem of fruit classification, where the classifications are of different types of 50 fruits only. I have the data of 50 fruits. Okay, let's say after 5 years there is a new species of fruit come. That, do you think will that model able to work?
No.
No, because it has not seen it, right? So this is a very small example of classification, but our our tasks are more complicated in the way. For example, if you have some documents, okay, and you want to sort your documents in some order, there is a algorithm that is running behind, which is going to sort your documents in some order, let's say on the basis of artificial intelligence or its subdomain, let's say. But after 2 years, will this model work? Question is like that. So the artificial general intelligence is more a big term where they are saying if you are creating some model, that please have in mind that will your model work after 5 or 10 years. Is it a generalizable model? If you are creating a robot, it is able to get some queries, get some meet your demands for some queries. So will it able to upgrade itself for the after next 5 years? So question is more like that. So that's why they termed this term journal intelligence. Journal, it means or it has two meaning. First meaning is more like for the generalizability. So the main goal is whether your model is going to be generalized. Okay, so it is not related whether the weights are updated or something. It's completely like when you start training your model, you don't know about the weights. It is automatically initialize, it is automatically updated, you don't worry about it. You cannot see it also, cannot see it in the sense, if you are going to see it also, you are not able to have an interpretation from that. Okay, second aspect of this journal intelligence is, can we have the systems which are more generalizable? It means same system, same model is working for fruit classification, same model may be working for the fruit disease. It means everything related to fruits can be solved from a simple single journal model. So there are two aspects. So in this aspect which I told you in the later part, we call it at foundation models. So those foundation models like your LLMs, right? In your chat GPT, you ask question with the what, you ask question with why, reasoning, you ask question with summarization, you ask question with different types of in different types of ways, it is able to answer you. So it's a AGI part, that is a generalized concept, journal concept. It means anything that is related to the text, if it is given to it, it is able to answer you. So this is artificial general intelligence that you are talking about. Am I able to answer it?
Yes, ma'am. But what I'm asking is like, you've answered it to a significant level, but still my question would be like, when a prompt is such a big and it has a too much of context window. Okay, when the context window is too much big.
Okay, okay, so how you will proceed, right? Your question is like that. It
Yeah.
means that you are saying ki, let's say if you are giving a 10 word sentence or 1000 word sentence, how it will be affecting, how it will be processing, is it?
Hmm.
So actually thing is like that. We What I tell you about foundation models, so what they do is, it is not dependent on the input size. It's more like that they have a model which captures features out of it. Okay, so this feature extraction part is independent on the input size. It extract the features in some fixed dimension. For example, if you're talking about text, okay, so if your input is a text, it will convert into a feature of, let's say, 100 dimension. 100 means a array of 100 values. If you are giving a video, it will also convert this video into a 100 dimension feature. If you are giving an image, it will again convert it into a 100 dimension feature. So now this 100 dimension will be constant, and now the actual model which is working for your objective will be taking this as input. So whether your input is of 100 size, whether your input is of 1000 size, we have mechanism that can tackle that.
So it doesn't really matter.
No, it doesn't matter. Means we have ways out of it. It's not, I would not say ki it does not matter. Obviously if your system is just trained for the fixed let's say if your system is completely trained on images, images are of fixed size. Okay, let's say the images of 100 cross 100 with 3 channels, it will give you good outputs. But if you are giving your system with more type of images, more type of dimensions, then deep learning say it is not a problem to us, but introduce one module to handle that. That's it. Okay.
Okay, okay, ma'am.
Hmm. Okay.
Ma'am, I have
All
a
right.
question from last week. It is about the polynomial kernel with P dimensional, if you add a degree D, it becomes P plus D and D. That part I didn't get. How did that come up? It's
Wait,
a kernel link question from last
I'll
week.
just open the slide. Maybe, do you know the slide number?
I don't know the slide number. I know the question. Question
Wait,
5.
question 5? Okay, wait, V4, right?
Yes.
Is this the question?
Yes, ma'am.
Consider a polynomial degree kernel of degree d operating on p-dimensional input vectors. What is the dimension of the feature space induced by this kernel? Okay, p plus d and d.
Yes, so I understand the P part of it, P dimensional P output. I get that much, but then the D part, I don't know how
Consider
what.
a polynomial of degree d. What is the name? Feature space. Feature space. Wait a minute. We have polynomial kernel here, right? Okay, this is the polynomial kernel. So look, this is your uh, p plus d, right?
This is P. That one, that right at the beginning, that was P. That much I got it. It's a D part. So
To
H1x, H2x is P. So that's six dimensions.
six
Uh,
dimensions, and
yes.
you have it in the wait a minute. It is a 2D space x1 x2. Okay, ठीक है कि x1 x2, it means that it is a 6G space d plus g polynomial. It is having a polynomial of 6 squared. Is it 4 1 3 4 5? Wait, I have to look for it. Okay, I'll let you just put an email. I'll look and answer you properly.
Sure.
Okay. Have I not mentioned any details? Okay, I have not put any. Sure, I'll just give me a email. Drop an email. I'll answer it there.
Yes,
I
ma'am.
have to look. I have to look once. Okay. All right. Wait a minute. It is p plus d cross d. It means it is p plus d आपके रहेंगे. It is p plus d will be columns and d rows. D rows means if you have for each dimension there will be p plus d vectors. Okay. Okay. Maybe it's more like for each degree you have some feature space for each degree, and for okay, all right. I'll find the final proper answer and let you know. Okay. All right. Any more questions?
Ma'am,
Hmm.
around a few weeks ago, in your session, I'd asked a question which is regarding to the development, wherein I'd asked you about developing an application which does the job of recording a lecture and summarizes it into like 15 to 20 sentences depending on the amount of things that are being spoken in the lecture. uh, the plan is to embed an large language model into the app itself. uh,
Okay.
now, I wanted to know that what are the technical implications of it, and I just want to discuss the approach. Would you be interested in
Sure.
discussing that?
It's not an issue. Actually, you have not shared this information with me. Maybe with the other TA, because I have not heard this summarization tool before. Secondly, I don't work in LLMs. I don't have means I know the basics of LLMs, but I don't have proper knowledge that how this text and voices are working. I generally work in computer vision. Okay, so if you have something, just write a proposal, send it to me. If I think I can be of any help, then it's good. Otherwise, I let you know.
Okay, ma'am. Just share me your email address so that. Okay, ma'am. Got it.
Okay, all right. Then good to go. Any more doubts? All right, see you then next week, same time. Okay, till then, okay, bye bye.